Okay, so this is Unit 4E, solving simultaneous equations analytically. When you see that word analytically, it basically means like with a paper and pencil. So in the last unit, we had a system of equations, we had graphs or intersection, we needed to use the calculator. So the questions are there questions that could be asked on the part one? The answer is yeah. So first of all, I need you to go through that Desmos stuff with the conics. And so now you're back. So in the last unit, we saw, you were given two equations like y equals e to the x and y equals 4 minus x squared. And maybe you were able to graph it. So maybe you were able to, you could, make your axis. Maybe you can make your graph. And when x equals 0, this is 1. And we know this is a parabola, it's a frown, so we kind of know it looks like this, because this is 4. And so we know that there's two intersection points, but when we use our tools for solving systems of equations, we're stuck. You might have said, okay, substitute this in for y, and so you get one equation with one unknown. You get e to the x equals 4 minus x squared, and you're like, I can't solve this. And you can without a calculator. So it can't be done analytically. But there are equations that you can solve analytically, and those are the ones where we have the intersection of two lines, or more specifically, line and conic, line and parabola, line and circle, line and an ellipse. You're not responsible for knowing the ellipse and circles and hyperbolas, but they might give you the equation. So let's take a look. So you're asked to find the intersection or sum of the line 2y minus y equals 1 and y equals x squared minus 3x plus 5. And so your first thing might be to substitute, you have a couple of options. Either you can solve for y, and stick it in there, or I can simply take this and stick it in there, right? I can do that. And so my new equation is 2x minus x squared plus 3x minus 5 equals 1, right? And then you would say, okay, it's a quadratic now. So I'm going to set everything to equal to 0. So I have negative x squared, right, plus 5x minus 6 equals 0. All right. Maybe I'm going to multiply everything by negative 1, right? Because y equals x squared minus 5x plus 6 equals 0. And so the question is, we saw from the Desmos exercise, we might want to ask ourselves before we solve it and find the actual points, does this equation tell us how many points of intersection? And the idea is yes. The discriminant tells us the number of intersection points between the line and the conic. So once you've substituted in, you've created a quadratic. If the discriminant is greater than 0, there's 2 points of intersection. If the discriminant is equal to 0, the line is tangent to the conic. I'm not saying it's like the line is not necessarily the axis. Once again, it's like a line just touching the parabola, or it's just touching the circle, or touching the hyperbola. So it's tangent to the conic. And if the discriminant is less than 0, there's no points of intersection. Intersection. Well, we can see from this equation that the discriminant, we can see here that the discriminant, I need a new pen. Oh, here's a new pen. So we can see from the discriminant here, right, it's equal to 25 minus 4 times 1 times 6, which is 1, and that's greater than 0. So we know this line is crossing the parabola in 2 places. Well, let's move on. What are those 2 places? So there's 2 points of intersection. And so we simply solve it. We know that we have x minus 3 times x minus 2 equals 0. So x equals 3, and we can plug it back in here. I can say, okay, that means 2 times 3 minus y equals 1. 6 minus what gives me 1? Y equals 5. And then I can say x equals 2. Plug that back in here. I have 4 minus y equals 1. Y equals 3. So I know my 2 points of intersection is 3, 5 and 2, 3. If you absolutely need to, yes, I know teachers say check your work. Okay, let's plug it back in. 3 squared is 9. 9 minus 9 is 0. Plus 5, 5. Good. Let's plug 2, 3 into my parabola. 2 squared is 4. 4 minus 6. What's 4 minus 6? 2. No, negative 2. Negative 2 plus 5, 3. Nice. Let's try another one. This one's a little more tedious. It's in the book, and they say, given 2 lines, x plus y equals k, and what is this? The circle, it's a circle because why is it a circle? Let's see, x squared minus 4x plus y squared plus 6y equals 12. How do we know it's a circle? Well, we know because the coefficients in front of x and y are the same, and it's positive x squared and positive y squared. They want to know what values of k are there 2 points of intersection. Excuse me. This is a lot of tedious algebra work, but it goes quickly. Just keep your eye on the ball. It might not show up on the AB exam, but it's good practice to make sure that you keep your eye. So, any suggestions? Yeah, we're going to solve for y. So we're going to solve for y. So we have y equals k minus x. And then what are we going to do with that? We're going to substitute this back into here. Okay. So let's get to work. We have x squared minus 4x plus k minus x squared plus 6 times k minus x equals 12. I see it's a quadratic with only x's, and I'm in my x squared terms, my x terms, and my constant. Let's figure this out. So we have x squared minus 4x, expand this, plus k squared minus 2kx, sorry, plus x squared plus 6x minus 6k minus 6x equals 12. Can you see that? Yes. Let's bring this all together. So I'm gonna, I know these are my x squared terms. These are my x terms. And I'm drawing another color here, green. These are my constants. Remember, k is just a number, so we keep it together. So let's organize this a little better. We have 2x squared. You know what? Maybe should I use different colors? Nah, we're good because you're big kids, right? What do we have here? Negative 4, negative 6, negative 2k, minus 10 plus 2k, x, plus k squared plus 6k minus 12 equals 0. Sorry. Nice. Okay. What's going on here? Well, we're asked to find 2 points of intersection. Therefore, my discriminant needs to be greater than 0. Okay. My discriminant needs to be greater than 0. Remember, the discriminant is b squared minus 4ac. So, it's negative 10 plus 2k. I'm getting rid of the negative because it's getting squared out. So it's 10 plus 2k squared minus 4a, this whole trinomial. And we need this to be greater than 0. Once again, this is just algebra. It's not difficult. It's tedious. Do not mix up tedious with difficult. Do not mix up tedious with difficult. Just work through the problem. Do not stop. Take it to its end. If you're doing the work, you're getting method points along the line. You might just not get the answer. So you know what? It's a 7-point problem. You're getting 6 points. You're just not getting the last point. Don't stop. Let's keep going. 100 plus 40k plus 4k minus 8k squared. 4k squared minus 8k squared minus 48k, right, plus 96 is greater than 0. Let's simplify. Negative 4k squared minus 8k plus 196 is greater than 0. Right? Let's keep going. I'm going to multiply through a negative 4. What happens when I multiply by negative 4? You flip the inequality. Can everyone see this? Oh, you know what? I'm sorry.